looking at the review exercises on page 562 of the textbook for chapter 9, section 9.1. We're going to do the evens. Start with problem number 2. It says, solve each equation by using the square root property or completing the square. So what we want is for one side of the equation to be a perfect square. So see that one's squared right there? When one side of the equation is a perfect square, square rooting both sides of the equation allows us to solve the quadratic. So when you square root both sides of the equation, don't forget the plus minus. So p squared equals 3, then the square root both sides, don't forget the plus minus, and that gives you p equals plus square root of 3 and negative square root of 3. Those could actually go in curly brackets because I can name them each, and in numerical order, negative square root of 3 and the square root of 3. I don't even know what that number is, but I know that the negative one's going to come before the positive one. So that's your answer right there for problem number 2. So remember the square root property. If I square root both sides of an equation, don't forget the plus minus. If I square both sides of an equation, not square root, but square both sides of the equation, then that means you're going to have to check your original problem because you might have gotten more answers than you actually needed, or that actually work, I should say. So both of those are special cases. So don't forget, square root both sides, don't forget the plus minus, square both sides, check your answers. All right, so that was the square root. All right, problem number 4, we actually have to have, we're supposed to be able to use imaginary numbers. We don't do imaginary numbers in this 10-10 class. See, if I square root both sides of the equation, I'll have the square root of negative 25. So that's not going to give me a real answer. So just so that we actually have something to practice, let's take that away. Okay, so because in our class, in our 10-10 class, we're not going to have negative square roots. In the future, you might, those are imaginary, but we're dealing with the real number system. So let's get rid of that just so that we have one to practice. This side is perfectly squared, so I can square root both sides. Don't forget the plus minus. When I do that, I have 3x minus 2 equals positive square root of 25 is 5, and I also have 3x minus 2 equals the negative square root of 25 is negative 5. All right, and then you're going to solve each of those equations to find the actual answer, plus 2. So I have 3x equals 7, divide both sides by 3, x equals 7/3. That's one of my solutions. And then here, add 2 to both sides, and I get 3x equals negative 3, divide both sides by 3, and x equals negative 1. So I have 2 solutions, negative 1 and 7/3. When I can name every one of my pieces, I put them in curly brackets like this. Okay, so in real life, that's not the answer to number 4 because in number 4 we had a negative right there. But this rewritten so that we have a positive, then we can actually get solutions. So we can just see how it works. Because what we want out of problem number 6 is to get something that looks like that. Now remember in problem number 4, we had something right here that was squared and it was equal to something else. So if we can get our equation to take on that form, then I can square root both sides of the equation. But problem number 6 says 2x squared minus 3x equals negative 1. Okay, so it's not in that form, so we want to put it into that form. Now when I had something like this and a binomial squared, when I multiply that out, that's foiling. Okay, so you'd have to FOIL that all out. So this right here, if I wrote this 1 over here, is a quadratic equation that we can turn into a perfect square trinomial. In order to do that, we have to start first with a leading coefficient of 1. So let's divide everything by 2, and that gives me x squared minus 3/2 x. I'm going to leave a space right here, equals negative 1/2. All right? I want to find the number that's going to go right here that's going to make this a perfect square trinomial. Now, because I have an equation, I can add whatever I want to both sides of the equation. So whatever is going to work nicely right here, I can add to both sides of my equation and maintain truthfulness. So the way that I do that is I take this middle term right here, this middle coefficient of negative 3/2, and I want half of that. So what is half of negative 3/2? It is negative 3/4. Okay, so that's the number that's going to go right here so that I have a perfect square. -3/4. Now, when I have two of those, it gives me that back. -3/4 and -3/4 gives me -6/4, which is -3/2 when I simplify it. However, this last bit, squared, is what's going to go right here. And that thing right there is 9/16. So 9/16 is the number that's missing right there in order to make this a perfect square trinomial. Add it to both sides of the equation, and when you factor this, you'll get this right here. And then we got to simplify this. We want a common denominator, 8/8. So I have -8/16 plus 9/16 is 1/16. All right, so now that I have this perfect square thing here equal to something else, I can square root both sides. Don't forget the plus minus. And that gives me x minus 3/4 equals 1/4, and x minus 3/4 equals -1/4. Okay, so I'm going to solve each of these pieces. This one is plus 3/4, plus 3/4, plus 3/4, plus 3/4. All right, so for this one I get x equals 4/4, which is 1. And this one I get x equals 2/4, which is 1/2. So my answers are 1/2 and 1 for problem number 6. Okay, this is called completing the square, and you can use it to find solutions like we've done here, but really we don't use it hardly ever for this. We will end up using this skill again of finding that little number that's going to make it a perfect square trinomial. We will end up using that later when we're solving for or trying to put something in a form for the equation of a circle or an ellipse. But completing the square is kind of obsolete once we learn the quadratic formula, which is the very next section. First,